Hello, welcome all to Anudeep YourStudyBuddy. Today we are going to discuss about a topic called matrices. So let us understand few basics. We are going to discuss about the basic concepts of matrices. That is, what is a matrix, dimension of a matrix, determinant of a matrix, and multiplication of matrix. So let us understand the basic definition of matrix is arrangement of any number in two square brackets. So these are the two square brackets and you're arranging numbers between them. So it can be 1, 2, 3, 3, 5, 6. So this is what is a matrix. So both are the matrices, but the difference between them is because of the dimension of a matrix. So what is the dimension? Dimension tells you how many rows. These are the rows. This is a row 1. This is a row 2. This is column 1. This is column 2. Again here the row 1, row 2, column 1, column 2, column 3. So what does the dimension tells you? Dimension of a matrix tells you how many rows and columns there are present inside the matrix. So as you can guess, in the first case there are 2 rows and 2 columns. So 2 by 2 is the dimension of the first matrix. In the second matrix we have 2 rows and 3 columns. So we always write row first followed by the column number. So 2 by 3 is a dimension of a second matrix. So this is how you know. Here, when we are taking the multiplication of a matrix, the matrices should be compatible. So that means the column number of a first matrix and row number of the second matrix, they should be same. They should match. Then only we say that the matrices are compatible and we can take the product of the two matrices. We can always take the product of any square matrix because in a square matrix, as you can see, if it is a 2 by 2 dimension, second matrix is also 2 by 2, it follows the concept of compatibility. So here, what we have to understand, before we start multiplying any two matrices, we need to check what are the dimension of a matrix given to you, and if they are same, if they are compatible, then only we can proceed with the multiplication. So now let us solve one problem on multiplication. So let us now see how to multiply the two matrices. We have given the matrix A and matrix B. Here matrix A has, it's a 2 by 2 dimensional matrix and it is the element 1, 2, 2, 3. Matrix B is of the dimension 2 into 3, that is 2 rows and 3 columns it has. So 2 by 3 is the dimension for the matrix B. So when we are multiplying, we are going to use this formula. The formula is row 1 of first matrix should be multiplied with the column 1 of the second matrix to generate the first element in the product matrix of A cross B. So first case that we need to, before we are proceeding with the multiplication, we have now to check if these two matrices are compatible. And as we have discussed the definition, this column and row number should match. So yes, these two matrices are compatible. And the resultant matrix will be 2 by 3. That is, there will be 2 rows and 3 columns. So this is what is the resultant matrix. And for this, for each of the element, we are going to evaluate the formula R1C1. That is a row of the first column and a column of the second matrix. Row of the first matrix and column of the second matrix. So R1C1 is nothing but the corresponding elements of row element with the corresponding element of the column element. So here 1 should be multiplied with 2. So when I am writing it, here it will be 1 into 2 plus 2 into 3. Similarly, for the second element, it is R1 into C2. That is first row should be multiplied with the second column. So it will be 1 into 3 plus 2 into 4. Next element will be 1 into 4 plus 2 into 5. So like we have prepared the first row of the resultant matrix, second row will be R2, that is row 2 of the first matrix into column of the respective second matrix. So R2C1, R2C2. So we'll be getting 2 into 2 plus 3 into 3. Similarly, we can proceed with the other elements. So what is the result that we have? 1 into 2 is 2 plus 2 into 3 is 6. So when we add up the corresponding elements, this is what is the answer of the multiplication of two matrices. So what are the things that you have to keep in mind when you proceed for the multiplication? First, check the compatibility of the matrix. If the matrices are compatible, then proceed with the rule of R1C1, R1C2 and then calculate what are the values after multiplication That is what is the answer of the resultant matrix. So now let us understand how to calculate the determinant of a matrix. So A is a matrix given to you. A is of the dimension 2 by 2. There are 2 rows and 2 columns, right? So for this, when we are finding out the determinant, we use a notation 2 vertical bars enclosed by the matrix name, and it is equal to, the rule is AD minus BC. So if it is ABCD, I denote the element as ABCD, then AD minus BC is a formula to evaluate a determinant for the 2 by 2 order determinant of matrix. So here what we can get, it is 1 into 4 minus 2 into 3. It is very simple. 4 minus 6, that is minus 2 is the answer. So here you have to notice that when we have square matrix, then we obtain the determinant for that matrix. So as here the matrix is 2 by 2 order, it is square. Square matrix is nothing but when the rows and column number they are same. Again, for the second case, here the matrix B is of the dimension 3 by 3. There are 3 rows and 3 columns. Again, it is a square matrix. We can obtain the determinant of this matrix B, denoted as vertical bar and B. Now to find out the determinant of the matrix B, this formula will be used. It is at the position A11. Number 2 is at the position of A12. So for the first row, if I can denote the elements in the matrix by its position, then the formula becomes A11 into M11. M11 is a minor of the element A11. Minor is obtained by deleting the row and a column where this element is present. So element is at the position A11. So this is the position, and for this element, the minor will be obtained by deleting the row and the corresponding column for that element. So remaining elements, the determinant of the remaining elements will give the minor of the first. So here what will be obtained as A11 was 1 into determinant of M11 is 1, 3, 3, 2. Similarly, for the second formula, that is A12 minor of A12. Here, what is the number at A12 position? 2. So 2 will be written, and minor will be obtained by deleting the row and the column where that particular element is present. So what are the remaining elements? 2, 1, 3, 2. 2, 1, 3, 3, 2. Similarly, you can write for the last evaluation for the term A13 into M13 will be, last element is 3, and here the minor will be 2, 1 and 1, 3. Right? So this is the way you are going to obtain the determinant for the 3 by 3 order square matrix. Now let us complete the problem. It is 1 into, now again it is a 2 by 2 determinant. We know how to solve 2 by 2 determinant, right? So here it will be AD minus BC, that is 1 into 2, that is 2, minus 9, minus 2 into 4, minus 3, plus 3 into 6, minus 1. So here it will be minus 7, minus 2 into plus 1, that is minus 2, 6 minus 1, that is plus 5 into 3, that is 15, plus 6. So that is what is the answer. So in today's video, we have discussed about what is a matrix, what is the dimension of a matrix, how to multiply two matrices, what is a condition for the compatibility of the matrix, and we also discuss about how to calculate a determinant of the given matrix. So this is the basic concept, very basic concept that are needed to solve the problems in our 12th class book. So this is what we have covered today. Just stay tuned for the next upcoming video. See you very soon. Thank you.